Solar storms and what you didn't know about them. Imagine a world without electricity, internet, GPS, or satellites. A world where planes fall from the sky, nuclear power plants melt down, and millions of people die. Believe it or not, this isn't just a sci-fi scenario. It's a real threat that could happen any day due to something we don't often think about: solar storms. In this video, we will reveal the heartbreaking truths of the solar storms, how they pose a serious threat to humanity, and what we can do to prepare for the next big one. But before we dive into all that, let's first understand what a solar storm is. A solar storm is like a disturbance on the sun, which then spreads outward across the heliosphere, affecting the whole solar system, including our Earth, and its protective magnetic shield. These storms happen when the sun shoots out powerful bursts of energy, like solar flares, and coronal mass ejections. Think of it like the sun sending a speedy stream of electric charges and magnetic fields our way. It's almost like a cosmic outburst. Now, these solar storms are some of the most intriguing yet dangerous events our sun goes through. They start by launching particles and radiation from the sun, which then travel through space like a speeding bullet. The really strong ones can affect not just our Earth, but other planets in a matter of minutes or hours. Nowadays, we have lots of spacecraft studying the sun, so we get pretty quick warnings when a storm is on the horizon. This helps people who run satellites and other space missions prepare for the space weather that's headed our way. Now, the big question is, how bad can these storms be? Well, when the sun gets a bit rowdy, an outcome can range from something that is as harmless as a spectacular display of northern and southern lights to something much worse. The charged particles released by the sun have various effects on our atmosphere. During a powerful solar storm, these particle clouds interact with our magnetic field, leading to strong electrical currents that can harm the technology we rely on in our daily lives. The most powerful storms can even wreak havoc on spacecraft and astronauts in space and mess with systems right here on our planet. In the worst-case scenarios, solar storms have caused massive power grid failures and disrupted communication satellites. They can even bring our communication and navigation systems to a grinding halt. Some experts have testified before Congress that space weather can impact our ability to make phone calls, surf the internet, conduct financial transactions, travel by plane, train, or ship, and even use GPS for navigation in our cars. So when the sun stirs up a bit of space weather due to a solar storm, it's something we all need to be aware of, as it can significantly affect our daily lives. There are several major types of solar storms, including solar flares that are like giant bursts of protons from the sun's atmosphere, coronal mass ejections, CME, that are massive releases of plasma and magnetism from the sun's surface. They can happen in any direction and often plow through the solar wind and the entire solar system. Some of them can travel at speeds of several million miles per hour. There's also one called geomagnetic storms. These occur when the sun's outbursts interact with the Earth's magnetic field. Geomagnetic storms have the potential to cause chaos on Earth. In 1989, for instance, a geomagnetic storm plunged the entire Canadian province of Quebec into darkness within just 90 seconds, leaving 6 million people without power for 9 hours. It also damaged transformers as far away as New Jersey, including one at a nuclear power plant, and nearly destabilized U.S. power grids from the eastern seaboard to the Pacific Northwest. And lastly, there's the solar particle events, SPE. These mainly consist of protons and other high-energy charged particles. They're believed to be released by shocks formed at the front of CMEs and other solar flares. But why do all of these solar events happen in the first place? The sun, like clockwork, goes through cycles of high and low activity. One of the most familiar cycles is the 11-year solar cycle, though there are other cycles tracking different solar changes over longer time frames. For our purposes, the 11-year cycle is the one most closely tied to the kinds of solar storms that can affect our planet. And what triggers this cycle? Well, it's not entirely clear, and experts who study the sun continue to debate the underlying causes. One theory involves something called the solar dynamo, which is the interior process responsible for generating the sun's magnetic field. However, what precisely drives this process remains a topic of ongoing research. One way to think of it is that the sun's internal magnetic field gets twisted as the sun rotates. As this twisting occurs, magnetic field lines can pierce the surface, preventing hot gas from rising to the surface. This creates areas that are cooler compared to the rest of the Sun's surface, with temperatures around 4,500 Kelvin, while the Sun's typical surface temperature hovers around 6,000 Kelvin. These cooler areas appear as dark spots, commonly known as sunspots, set against the Sun's golden glow. As charged particles and heated gas flow from these sunspots, they give rise to dazzling arcs of light, known as prominences. These are all natural elements of the Sun's appearance. Let's look at some of the worst solar storms in history. One of the most powerful solar storms in recorded history is known as the Carrington Event, which occurred in 1859. This flare was followed by a coronal mass ejection, CME, a colossal cloud of plasma and magnetic fields that was flung into space at a staggering speed of approximately 7.5 million kilometers per hour. About 17 hours later, this CME reached Earth, triggering a severe geomagnetic storm that persisted for several days. Remarkably, it is believed to be the largest solar storm in the past 500 years, as noted by NASA. Another significant solar storm in 1921, known as the 1921 geomagnetic storm, which is widely regarded as the most substantial solar storm recorded in the 20th century. It impacted electrical systems, causing short circuits in wires and disabling signaling systems, particularly in New York. More solar storms followed in the years to come, with one knocking out electrical grids in Canada in 1989. Additionally, there were notable incidents in 2000, 2003, and the 2006 flare, which was potent enough to damage the solar X-ray imager instrument on the GOES-13 satellite that captured its image. Even more recently, in October 2023, there was a solar storm scare. According to a report by Space Weather, NOAA forecasters indicated that a CME might brush Earth's magnetic field on October 7th. This CME had been propelled by a solar explosion near the Sun's northeast limb, leaving the Sun on October 3rd. The anticipating glancing impact could have incited a minor G1 class geomagnetic storm. Thankfully, on October 10th, the official Space Weather Live X account reported a moderate M161 flare from Sunspot region 3452, with NASA sharing a video of the eruption. Since this event occurred in the eastern limb of the Sun, it appeared to miss Earth. Nonetheless, the unpredictability of these solar storms reminds us that their consequences go far beyond the notable effects previously mentioned. They can escalate to the point of posing a genuine threat to humanity. Very high-energy particles carried by coronal mass ejections can induce radiation poisoning in humans and other mammals. These storms can also knock satellites off their courses, potentially causing them to crash into Earth, putting many urban centers at risk. Some scientists have even speculated that migrating animals that rely on magnetoreception to navigate, such as birds and honeybees, might also be adversely affected by such events. Also, when a coronal mass ejection, CME, from the Sun collides with the Earth's atmosphere, it causes a temporary disruption in the Earth's magnetic field. The rapid fluctuations in geomagnetic fields resulting from this can induce currents in pipelines, a phenomenon known as geomagnetically induced currents. This can lead to a lot of challenges for pipeline engineers. Flow meters along the pipelines can start transmitting incorrect flow data, and the rate of corrosion on the pipelines can drastically escalate. In a twist of fortune, Earth narrowly avoided the expected CME strike on October 7th, as initially predicted by space experts. However, our luck may have run out, as recent concerns have arisen for Earth's safety. Recently, NOAA forecasters issued a warning about a co-rotating interaction region, CIR, that appears to be heading toward Earth. Also, as reported by spaceweather.com, there is a sunspot currently facing Earth with multiple magnetic poles in close proximity and all mixed up. NASA's Solar Dynamics Observatory shows sunspot AR3460 with numerous magnetic poles, both positive and negative, pressed closely together. This configuration could lead to a magnetic reconnection and the potential for a strong solar flare directed at Earth. Now the question is, should we be worried about this looming threat? The answer is yes. Let's know what you think about it in the comments section.